And this is the last experiment, that is determination of stability constant and donor acceptor ratio of cupric glycine complex pH titration method. Right, now we will be taking the two going for the calculation of pH titration method. So already we discussed in the methods of analysis regarding the pH titration method. So you will be getting the glycine as well as you have to prepare glycine complex. Next one is complex solution. First one is glycine solution, next one is complex solution, next one is 0.25 normality sodium hydroxide. So how we will prepare this glycine complex is by taking 250 grams of glycine and transfer into 1000 ml of vacuum filtered flask and make the volume to 100 ml. Next one is glycine plus cupric chloride complex, that is 250 mg it is there, right, but you take the 250 grams of glycine and 160 grams of cupric chloride and make transfer into 100 ml of the volumetric flask and make the volume to 100 ml, right. Next is you have to prepare 0.25 normality sodium hydroxide. Now we are preparing the glycine complex 100 ml, right. From this you take 75 grams in 250 ml beaker and gradually add 0.25 normality sodium hydroxide. Now similar, first one is only glycine solution, next one is glycine with cupric chloride solution. Now you take the 75 grams of the glycine. As you know that there is the pH meter, this is the temperature knob, and this one we have to adjust the knob, and this is the slope should be always at 100, right. Now whatever is, we have to standardize with the, first we have to standardize with the standard buffers. This is acid buffers, that is pH of 4, and this is the basic buffer, this is pH of 9.8. So this is already standardized pH meter. So it shows the pH of the water as 7.07, that is, first we have to adjust with the standard buffers, next we have to adjust with the water solution. The pH of the buffer, that is water, that is distilled water, we got as 7.05. Now we have to take 75 ml of the hydroxide. So this is the glycine solution which is of 75 ml, right. Now we have to add 0.25 normality sodium hydroxide by adjusting the stand above this solution. Now we have to adjust like this, 75 ml of the glycine, and this in this burette we have to take 0.25 normality sodium hydroxide, and you start adding 1 ml. You have to add 1 ml and you have to stir it with a glass. First you have to lift the electrode and you have to add 1 ml from this burette. You have to add 1 ml. So after adding of the 1 ml, you have to see the readings in the burette. Now you have to stop this knob and you have to dip the electrode into this beaker. Now you have to measure the pH. It will be now you have to measure the pH. Now it will be around 5.47. Again the same. Again you have to add the sodium hydroxide. You have to lift out the electrode. Again you have to add the sodium hydroxide 1 ml. After that you have to stir with a glass rod. Again you have to dip. So as we are adding the sodium hydroxide, the pH will go on increasing. So you have to note down what is the pH after addition of each sodium hydroxide solution, right? Now similarly you have to take out this. Similarly, you have to go for the calculation for the complex. In a beaker, you have to. So this is the complex that consisting of glycine as well as cupric chloride. For this, so you have to take 250 mg of the glycine and 160 mg of cupric chloride. You have to mix in 100 ml of water. From this, you have to take 75 ml. So as I took the 75 ml, again the same procedure. Before changing the solution, you have to clean the electrode with the tissue paper. Now you have to dip this and you have to measure the pH. It will be around 5.81. Now you have to add 1 ml of the sodium hydroxide. You have to add 1 ml of the sodium hydroxide solution from the burette. After that you have to shake with the glass rod, then you have to note down the pH. As you note down the pH will be increasing because we are adding the base. Similarly, you have to go for up to 10 ml. You have to add the sodium hydroxide and you have to note down the pH.